welcome back, everyone. And welcome back, Ray. Yes, Ray is here again. How are you doing?
I'm doing fine, thank you. Yeah, glad to be back here for the second session.
Second session of the day, one in Maven and one in microservices and Kubernetes.
Right.
And you also were present in Generation 2018 with the Docker session as well. Are you not getting tired of us?
No way. It's been great. You're all awesome.
Great.
So
Can
thanks
we
for
book
having
you?
me here.
Can we book you for 2021 then?
I would love to come. Yes, absolutely.
we expect to have you here, but next time, hopefully, on site again on those marvelous rooms of the Convento. So we are close to the closing keynote. We only have a race session, and then we have Rafael Benavides here on Medina, and then we close up with Venkat on the closing keynote. So we are reaching the end of Generation Online. But for now, let's stay with Ray. And so, Ray, whenever you're ready.
Okay.
Go ahead.
Thank you. Yeah. So thanks everyone for joining the session. And I know it's probably late in some of the countries, so thanks for staying up. And if you just got up, thanks for joining us. My name is Ray. I'm a developer advocate for Google Cloud, and I love to bring some of our technology to developers all over the world, especially for Java developers. I've been a Java developer for a long time, almost more than 15 years now. And I'm a Java champion. And I also started the project with the engineering team here called Spring Cloud GCP. If you ever want to try Google Cloud with Spring Boot, let me know because this project may actually be very useful for you. If you got questions, you can find me on Twitter, which is @Satanism. And aside from technology, I love to travel. Of course, traveling is very difficult nowadays, but I really enjoy traveling. I love to see the world. And this photo on the right is very special to me. And you can see it's in the middle of the desert. Long story short, I was backpacking in Asia for about 4 months. And I came across this city in northern China where they didn't have any hostels for backpackers to stay. I was a backpacker. And so they only had expensive hotels. So I asked around and see if there are any places where I can stay cheaply. And two different people, completely unrelated, told me that if you take a bus to this middle of the nowhere city and you transfer to a car to the entrance of the desert, and then you walk in the desert for 4 hours in southwest direction, then you will find an oasis and you can stay in the oasis for free. And I heard the word free, and I asked, which bus do I take? I don't know if anyone here walk in the desert alone by yourself for 4 hours in one direction. It is not the same as walking on the beach, right? Everyone's probably walk on the beach, but this is not the same. Okay. And basically, when somebody tells you to walk in the desert in one direction for 4 hours, you hold on to your compass and you walk. Doesn't matter what's in front of you. You go up and down these sand dunes you can see, and the sand is really soft. So every step that you take, you're going to sink a little bit, and you have to pull your foot out to take the next step. And you go up and down these sand dunes, and you have your pack. You got water. It was hot. It was dry. It reminded me of writing a J2EE application back in the day. Okay, I was on vacation. I'm like, why am I doing this again? This feels like work, but much harder. Okay. However, the end is beautiful. This is the real photo that I took from the oasis. It was absolutely wonderful. I'm very happy that I took that hike for 4 hours in the desert. But this is where we all want to get to as engineers and developers. We want to get to this production, to this beautiful place where we see users using our systems, where we see value being created. However, the road to production is not always easy. And so this is what I do. And today, I hope to share with you some of the things I learned from doing a project to production last year using microservices in Kubernetes. And I want to share some of my learnings with you all so that you can get to this beautiful place yourself, hopefully much quicker without having to go through the desert yourself. Okay, so I cannot name the project, unfortunately, because it's an internal project. What I can say, though, is that it is a project that's it's been developed by using Spring Boot, using microservices patterns, and deployed into Kubernetes with all the technology that we hear so much about, but we are able to bring this into production and it's ready to serve the real systems, right? And the infrastructure looks like something like this. This is pretty much close to everything that we put on here. There's, of course, a little bit more in the production system. But long story short, we have a Kubernetes cluster that's running on Google Cloud. It's a private cluster. What that means is that it only has private IPs because it's part of the ways to secure your network perimeter. And we are only routing traffic requests through our load balancer. So there is the Google Cloud load balancer in the front. And for the non-prod environments, because non-prod is for testing and for our internal tests and UAT tests, and these are not open to the public. We don't want anyone to just find the IP address and get in. And so for the non-prod environment, we also proxy it with something called the identity-aware proxy. So what it's going to do is to automatically require authentication. So we didn't really need to add additional OAuth or any security functionality to secure our services in the way that you would expect. But just by adding this IAP proxy, now all of the services are secured automatically through the endpoint. Okay, and then inside of this architecture, we also have all the microservices running in a namespace in Kubernetes, which is on the right-hand side. We're talking to SQL databases, and we also isolated our networking. So we're running a VPC, a virtual private computing network, and we control all of the egress that goes out of this network through NAT. And we're also using Istio to manage our service-to-service communication. Right, as you can see, this is pretty involved. And finally, we have monitoring tools and distributed tracing tools that we added to our environment as well. Okay. Now, the reason why we also have some of these things, like Prometheus, Grafana, and distributed tracing dashboards, even though Google Cloud has the same functionality, some of these services are actually running in a different environment that is done on GCP. And so we also need to make sure that our application can work in a hybrid environment. And that is really interesting for me because the same application needs to work both in GCP in a fully managed environment and also in a non-GCP environment where we do need to use some open source software that we need to manage. Okay, so that is the picture of this entire architecture for the project. It took several months to complete, of course. And one of the first things that when I joined the team, what I learned is that it's really easy in the cloud for us to create resources. Like you can click on the console, you can click on the UI, you can click everywhere to create this entire environment yourself. Okay, and that provisioning doesn't take too long, right? If you know the console, you can just navigate it. You can create the cluster in about 2 minutes. You can create all the networking in like a minute, right? It's very easy to do. However, what happened is now we need to recreate this environment from dev to QA. What happened next? Well, now people do not remember what they clicked on anymore, right? So there's a really important shift. This is so important that we shift from a ClickUp environment or type of provisioning to a GitHub provisioning. So that in the past, when we create all of this environment, is clicking around and also running a bunch of scripts. But at the end of the day, no one remembers how to recreate it anymore. And it's very important to document your environment as code or as configuration. And then you can recreate this entire environment via GitHub. And that's what we have done. So the first thing that I got there that I asked the team to do is to actually create infrastructure as code. And we are using Terraform behind the scenes so that we terraformed everything that we ever needed. So that goes to the Kubernetes cluster itself, all of the external dependencies like SQL databases or static IPs and VPC, any external resources that we need. We go so far into creating the SSL certificates and also laying down the basic infrastructure. So that at the end of the day, what you see is a picture like that, where everything in this environment is terraformed. Very, very important. And we open up just a namespace here that is ready for the application to deploy to. So when your application is ready to be running, you just have to deploy it into this namespace. And the Terraform script is able to create everything else for you. Okay. And now we can replicate this environment very easily from QA to prod or to dev and so on and so forth. Okay. Now, unfortunately, this is not a Terraform talk, right? So there's a lot of best practices to use Terraform. I'll just tell you a few things that we learned to do to use Terraform properly, right? So first of all is that you want to have all of your Terraform files organized by the environments that you want to create, right? It's very important that you're able to go to one directory that you know this is the dev environment, and you can just run tf apply, and you can share modules between these environments so that it's the same database that's being created, but the difference will be the size of the database or the number of CPUs, so that you can codify some of these into modules and you can reuse it in different environments. The other thing, of course, is that initially the team was running TF apply in their own computer, but they didn't really share the state of the cluster of the provisioning with anyone, right? So remember, if you run Terraform locally without a backend, then whatever that you Terraform, whatever that end state is recorded on your computer only. So in this case, it's very important for you to actually share that state via a backend. And you can do this with different type of databases or different backend. We choose to use Google Cloud Storage so that we can just share the state across all of the team members behind the scenes. Okay, so let's talk about the things that we want to deploy inside. Okay, but before able to deploy, we have to create these applications, right? So we're using Spring Boot, for example, and we're adopting all these technology. But one of the things that really help me understand the difference between dev and production environment is by going through, the actual exercise of, developing and also going to production. Because I think in the Kubernetes environments, a lot of people are saying that, hey, look, if you just create everything to be the same as production, everything will just work, right? Well, yes. However, the local development experience is not the same as the production experience, right? Because production is really, really hard. In production, we have to figure out all the security rules, all the networking rules, right? Anything else we need to lay into Kubernetes to harden the security constructs of Kubernetes, that all has to be done. However, in local development, if you just got started out of nothing, you will spend months to just create that production environment for your development before you even start developing anything, right? So it's very important to remember that, yes, it's a dream to have a development environment exactly like production, but I don't think we'll ever get there, because in local development environments, what we want is to focus on the developer productivity. We want to be able to iterate fast, and you want to not having to worry with all of the production setups, because the more that you add into your local environment, the more you have to troubleshoot. Okay, and we're gonna get into some of these issues later, but just remember they're not the same. But what you want to focus on in local development is how fast you can iterate and design your application. And one emphasis on design. It's all about your application. It has nothing to do with Kubernetes. If we talk about designing your application properly, designing your services properly, then it should be able to run anywhere, right? Kubernetes is just one of the many different deployment targets. In the past, we deploy into a PaaS. Prior to that, we deploy into other places. And now it's about Kubernetes. And tomorrow, who knows what this is going to be? So what is important is designing your app. And one of the most important things is to follow the 12-factor app, because I think that is the thing that has been tested and battle tested for so long, and is still the thing that's persisting even now. And I'm going to assume that it's going to persist in the future as well, because all of the factors are very fundamental in terms of designing your application well. And let's just take a look at the 12 factors real quick, right? There are 12 different requirements here, but everyone here should have at least one factor. Even if you have not heard about 12 factor, or you don't think you have 12 factor, everyone should have at least one factor, which is checking your code. If you're not checking your code, you got checking your code like today, right after the talk. But everyone should have at least one factor, right? But if you look at all of the 12-factor rules here, configuration, don't store your configuration in your application, but or hard-coded in your application or hard-coded in your files, but externalize it, making in var, or somehow being able to get it from the external environment. That's really important. Being able to scale your application via stateless processes, that's pretty much microservices. Being able to bind to different port, that's pretty important, right? And so on and so forth. And logs, like all of these things are tested through time, and Kubernetes just to happen to have all the facilities that supports the 12-factor application really, really well. So start from there. That's number one. The second thing about developing microservices, with or without Kubernetes, is that you do need to test your services with other services too. And for that, you may need to consider multiple layers of tests. I've been through this a couple of times already to produce production microservices just recently, just as recent as like yesterday. I'm working on another project right now. And what is important is that we don't want to test everything in Kubernetes. That is not a test. That is the end state. What we need to test is the microservices themselves and the ability to interact with another service. And also being able to test everything else that we might otherwise expect from the container, right? So for example, if I want to test another service, my interaction with another service, I will start off with a mock, right, to make sure that the interaction is there. And then I will move on to the integration test where I may use contracts or wire mock, where I actually mock the actual call, and then I get the actual response back to make sure that the networking and everything else is there. And then I can test resiliency. I can test the retries. It always starts from the test. And in many cases where our application needs to talk to a database, right? In Kubernetes, you would think, well, let's just start a container, a deployment for a database, and let's just test in Kubernetes. But that will ask you to go into that Kubernetes environment again. What I do like to do myself is nowadays, which is to write an integration test that uses test containers. This is so good and so very much useful. So I do have an example here that uses test containers. Here I have a very simple Spring Boot app as an example where I am using a PostgreSQL database behind the scenes. It has nothing but an entity and a repository. And if I were to run this application right now, right, if I say Spring Boot run, this will fail. And this will fail because I don't have a Postgres database running. At least I don't think I do. Yep, I don't have it running, and it's going to fail, right? And now we have to go and install the database and all of that. Of course, it's getting a lot easier if you run Docker. So you can say Docker run, Docker run. And you can run a Postgres database behind the scenes. But unit test or integration test, you want these tests to be repeatable. So what is really important in a microservice is to have these self-encapsulating tests that you can validate its accuracy and correctness. So if I were to depend on a database, what's really important is for me to start the database consistently and reproduce the data that I actually want to test against, and then test it, and then shut down the database, and then recreate a database for the next test. And the easiest way to do this is by using test containers. So it's a really, really cool project. I've been using it for a while now. And so what you can do is to just include test containers as your test dependency. They do come with some utility test container components you can use. And then in your app or in your unit test, or in my case, it will be an integration test, you can just say, hey, I want to start a Postgres container when I start the test, right? So this hooks into the lifecycle. So you do need to annotate your test properly. And you can say, I want the container to use Postgres version 12. And here's the parameters I want to set. And then you can add additional calls into a script or something else that sets up the database for you, or you can use Spring Boot to bootstrap it for you. And then you can override the data source configuration to point to that specific test container. And so that when you run your test, remember, my application doesn't start, but my test will start. Because when you run the test, you will actually automatically start the test container behind the scenes. And it will start my Postgres container in my Docker daemon. And I continue to wait for it to run the test with the new configuration, and the test passes. This by far has been very, very helpful for me, either testing with external resource, or sometimes you can even spin up external services or external service stubs or mocks that you can use. So for example, in the cloud, rather than depending on the real cloud services, I can spin up emulators with this so that I can emulate my interaction with the cloud, right? And this will help you with the fidelity for the local development environment, which is what I do recommend. Always start from the test, make sure your test can work and can run, and then every other following steps will be significantly easier. Okay. What I also learned is that from Sergey Egorov, who wrote who wrote test containers, many of it, is also has a blog here that talks about how you can actually tie this into your application. So with Spring Boot, you can actually start your application that also starts the container. So you can completely bypass potentially Kubernetes or even Docker Compose, and you can just start your application that will start all the containers for you, which is super, super useful. Okay. So that's about your application and your services. Now, when we're talking about Kubernetes and microservices, microservices specifically, Another thing that people always ask is, well, there are two things. One is, how granular should my service be? And the other one is, should I use a mono-repo versus multi-repo? So I'm going to talk about mono-repo versus multi-repo first. This is like the defining question on what people, because we're writing code, right? So we have to decide where to check in the code, because that's the first factor in the 12-factor app. So we got to check it in, but do we do mono-repo or multi-repo? And to some people, this is a philosophical question of whether you're creating a distributed monolith or distributed service. Because if you're creating mono-repo, then even though you're creating multiple services, but they are still compiled and created at the same time, they're versioned at the same lifecycle. So potentially you could be creating a monolith that just happen to be running over a network. Or are you truly building a distributed services, right? That's really the difference. However, I think that through my learnings in this project, right, and many others, is that it really depends on many other factors, right? This is the philosophical ideal comparison, right? That we want to create distributed services, but the reality doesn't always match it. Why? Because there are so many pros and cons to either approach, and it depends truly on your current team structure, your current organization, and your current capabilities. Why? Because there are many, many things that's a lot easier in mono-repo. In mono-repo, you just need one repository, and so you can actually do your dependency management really, really easily. You can build with a single CI/CD pipeline. That's super easy to do. If you update one of the common libraries, you just rebuild the whole project and everything's up to date. Super easy to do. So initial velocity of a mono-repo is very fast, right? You can get started really quickly. However, we do know the long-term downside, which is that as your code base grows bigger and bigger, larger and larger, it's going to slow down the build. And we do observe this very quickly, right? But that is the downside of it. With a multi-repo, you can build each individual project much faster. However, initially to set this up, now you have to consider many, many things. You gotta figure out the naming convention for your repository. If you have common libraries, how do you actually make sure that other repository gets the latest version of your common library? Now you need ways or bots in GitHub that helps you to automate some of these dependency versions. CI/CD pipeline. Now, rather than CI/CD pipelining just one repository, you need to do it for multiple repositories. What if you get the CI/CD pipeline incorrectly the first time? Now you have to go back and fix every other ones, right? So there's always these pros and cons that you have to decide. So one of the things that we have done in this project, which I learned from one of the TLs in the project, is that he writes everything down into a document. And we discuss the pros and cons of all of their approaches. This is just one example of this, right? Mono-repo versus multi-repo. What is good, what is bad, and what do we decide on based on our current situation? We actually chose to go with mono-repo, okay, which is surprising, but it is the reality. Why? Because the team was familiar mostly with mono-repo. The team was very small. We started off with like a couple of people. There's no way for us to manage multiple repository at that time, and they needed to move fast. So we don't have time and the effort to actually improve the multi-repo experience. So we gotta move. So we have to make a choice, right? And we don't have all the existing dependency or artifact management infrastructure. Like, so for example, for Maven artifacts, where would you publish that? Like, do you need to use Nexus? Or do you want to use Artifactory? And now you have to set all of those things up and manage them. We didn't have time for that, and so we chose mono-repo. Right? So it's always a comparison, pros and cons against the reality. But the important thing is to write it down somewhere. However, as we're doing this, we're always anticipating that multi-repo still is the future, right? So even though we went in with the mono-repo style, but everything that we do in the mono-repo is still anticipating the multi-repo approach, right? So what that means is that we are able to design the repository. Again, I'm going to go back to design, which is really important. We design the repository in such a way that even though we started off with a mono-repo, we can still split it later, okay? It's completely splittable. And we are able to split a few services out, in the past, and we can split all of them out if we want to. Okay, and that is about designing and anticipating for the future. Same thing with the service granularity, right? Do you start with very fine-grained services, or do you start from a bigger service, right? And in some cases, a monolith service, which is completely fine. you do have to compare the pros and cons of the approach based on your current situation. And maybe it makes sense to make a monolithic service to start with, which is fine. However, even if you have done that, you need to anticipate the change so that in the future, you definitely need and will break down those services into finer grained deployment units as opposed to a single unit, right? So you have to design it well to anticipate this change. So for example, in the build structure for our mono-repo, we make sure that every service is broken out, right, individually, and their dependencies are done not via the file path, but via the actual artifacts. So that we're using Gradle to do that. So for example, we can apply some common Gradle file, which we know we can extract even if we have a multi-repo service. But also for all of the dependencies, like these dependencies that depends on the project, they can easily be extracted and refactored to depend on the actual Maven artifact, right? So that when we extract it from the mono-repo, like you don't have to change a lot in your application at all, right? It's because every line here is about the dependency that you would otherwise just change the where they live, really. Okay. So here's the learnings for this particular section, which is consider the risk outside of the technical choices. And that's really important for me. Yes, it will be nice if everything is just a multi-repo and we can create multi-repo with a click and everything is just there. But the reality is that doesn't happen overnight, right? And so we have to consider all the issues outside of this technical choice and and move forward. However, always anticipate the change because your choices today may not be the best choice tomorrow, right? Which is reality. But you do need to anticipate that change and design things well. And my biggest takeaway was to always document the pros and cons and design decisions of why. Now, for the service-to-service communication, again, this has nothing to do with Kubernetes in general, right? Because Kubernetes to me is the deployment platform. So in this case, even for service-to-service communication, we talk about, well, we need to decide on, what protocol do we use, right? Do we use gRPC or do you REST? gRPC is nice because it's binary protocol. Everything has a protobuf definition, so you can define your payload up in front. For REST, it's really loosely coupled in a way, and everyone can go wild with the REST payload and the schema, right? But you also have to have discipline, so maybe you will end up using Open API, and you do need to have the schema for your payload anyways. Right? And we chose gRPC mostly because the people understand gRPC. It is an internal project, so people have been using gRPC or Stubby internally for a long time, and so for them, this was a natural choice. However, there are always downsides, which we did list, but they are okay with the downsides of using gRPC versus REST, and they make that choice. But the proto, it was really useful, of course, because the schema was really easy to write. It's very concise, unlike some of the schemas in the past, like WSDOs and even Open API schema. They can get really complicated sometimes, but gRPC is very straightforward in this case. And then with gRPC, we can then export it to other languages too. So even though our backend is in Java, our frontend is in TypeScript, and so they are able to convert these definitions from the proto file here, and then we can convert it into the front end so that the front end can also make the same call with the same payload. And now everything becomes type safe, and it's really, really nice. Okay. Now with the proto files or with schemas, again, there's always a choice of whether do you store the proto files with individual services or do you store the schemas globally in a single location, right? And I think that again, it's the same idea of whether we're being, choosing mono-repo versus multi-repo. There are pros and cons for all of them. And I think we ultimately chose to store, actually, it is actually a good choice to store all of these definitions with the service because your service defines the contract with that is willing to expose. So it makes total sense to document the contract along with the service itself, as opposed to document the contract in a global location somewhere else, right? So this is what we chose to do. So underneath each individual services, we have the proto file, which is the service contract and the payload definition that we are able to share with other services. And you can actually build the proto file into a jar. So now it becomes an artifact. And then your other applications who are trying to consume your service, you have access to the definition file itself. And what this will do is to actually take that definition and it will regenerate the client library for you. Okay, so you don't have to ever write your own clients anymore. You don't have to stub out your POJOs. This will just be all automated for you behind the scenes, which is again very convenient. And the way that we wrote this again is that, even though right now this is using Gradle's expression to get the file from my project, but it's also very possible to replace this so that it gets the file from the Maven Central or Maven repository instead. Okay. Now with gRPC, we also needed to expose the services up to the browser, right? Because the browser is the making all the user interactions, and they need to call back to the services that we have. Now, the thing is that most of the browsers don't speak gRPC, even though they support HTTP2, but they don't actually support everything that's required by gRPC. Okay, so what is necessary is some transcoding in between. And the transcoding is mostly well known as gRPC-Web or gRPC-Web. You can find the spec for that. And for us, we are using something called gRPC transcoding with Envoy. So in the Envoy proxy, the web proxy, it has built-in capability to actually translate the gRPC-Web, the regular HTTP1 payload, into gRPC call to the backend. We went even further by using something called Istio. Okay. Now, what is Istio? And what does that do? This also was very interesting for me because we made the choice to use it. The idea here is that Istio supports many of the capabilities that you need to manage your microservices to service communication. Okay, if you think about Kubernetes as a deployment target, Istio is a way for you to manage your service-to-service communication. So you can have routing rules to say, if a call made to /API/v1/auth service routed to this service for version 1, right? If the call came into a different URL, you can route it to somewhere else. So you can add these routing rules. But what's more important is that you can also add retry rules, right? So even though we're using Spring, we're not actually using the Spring Cloud OSS stack. We're not using, Hystrix. We're not using Thing, or we're not using Ribbon to do any of the load balancing and retries. We're just cutting down all of those things from our application, and we depend on Istio to do all the retry for us. And we also depend on it to do the circuit breaking and distributed tracing and monitoring. So we offload a lot of these concerns just to Istio out of the bat. And the way that it works is by, if you don't know Istio, this is how it works. Essentially that it deploys your application with a sidecar pattern. And so what happens is that your microservice runs alongside of the Istio proxy, which happens to be Envoy. And when you make a call out to another service, your request is intercepted by the proxy. And the proxy will then determine which backend to send to, because the proxy actually has a list of the backend you can load balance to. And you can also configure it to load balance differently. Okay. And the proxy will then forward the request to the target destination. And the target destination also intercepts the request via the proxy and determines whether you are able to make this call or not, because Istio has security rules. So you can secure your services and you can tighten it down to say only microservice A can call microservice B. And then once the proxy understands you can actually make the call, then it forwards the request to the actual service. But what is really interesting is that throughout this entire process, Istio actually can know, for example, how long did this request take? It can know all the topology of who is calling what, and you can know the performance metrics, and also that we can enforce these policies and security rules. But what is the most important is that what we needed, because we're running in untrusted environment, right? We're not just running in Google Cloud, we're running other places. So in these other untrusted environment, we wanted to have mutual TLS. So Istio can actually give you that capability as well, so that when I make a call out from service A to service B, that communication is automatically secured via mutual TLS, and so we don't have to worry about this. Now, that is the primary reason why we chose to use Istio. Okay, and then we can add all of these routing rules to it. So, for example, we can map, this particular prefix to a specific service. We can do canaries, and we can do blue-green deployments. We can even do traffic splitting with Istio too. So there's a lot of good things that comes out of this. and also the transcoding. So we, rather than configuring the proxies ourselves, we just tell Istio that this is a gRPC-Web port, and it will do the transcoding for you automatically behind the scenes. However, now all that being said, this is all in production. For local development, we don't use it at all. For local development, we want the environment to be as simple as possible so that we can iterate much, much faster. And so for the local development environment, we don't use Istio at all. We assume a few contracts that we will have in Istio, but other than that, we don't install this at all. And this is important because the more that you lay into your development environment, like if you were to use Istio, now everybody has to learn about Istio. That's number one. Number two is it is actually not that easy to learn. There are so many things that goes on behind the scenes, which if you have a team of 10, like a lot of people might be stuck, right? And if you do run into issues, you're gonna troubleshoot Istio as opposed to troubleshooting your application. And you might argue that, yeah, that's actually not bad because you do want to fix those issues up front and early, but that's fine. But you do that in the dev or in the testing environment, which you can find this out as well. Okay, focus on the code in the dev environment. For containers, the building the actual containers for these microservices, there are a lot of things to consider. Like I have a whole 1 hour talk around this, right? It gets very, very involved to understand how to actually create a container that is production ready. For example, how to make it small, how to layer it properly, how not to run as root, right? How do you create a small image and in the versioning, all of these things. But nowadays, I just say, I learned this from my friend, Matt Rabel, who works at a company called Okta. He always say, friends don't let friends write security or write authentication, right? Because authentication is, it's always the same, it's repetitive, and it's error prone. So what I'm going to copy him, and I'm going to say something different. I'm going to say, friend don't let friends write Docker files. Why? Because Docker files can also be complicated to write, it's repetitive, and it's also error prone. So whenever you can, automate the process. So nowadays, I just say, just jib it. If you haven't heard about jib, you can try this out. It's really just a plugin for your application, for your Java application. All you need to do is to add a plugin here. Yeah, there's the plugin. And you can say, I want to use jib to build my container. I want to build it to this container coordinate. I want to use this base image. And I want to not run as root. And that's really it. And there's no Docker file involved. In fact, there's a Docker file here. I will just go ahead and delete it because I don't need it at all, right? And then what I can do then is to say maven jib, let me see here, jib build, yeah. So I can say compile and maven jib build. I'm going to skip the test for now, skip test. And what this will do is to actually compile the code, create a container for me, and go straight to my container registry. There's no Docker file whatsoever. And that is super, super neat, okay? I know that in Spring Boot 2.3, you can also use the build pack with Spring Boot. Again, you don't need to write a Docker file. Just use the automated tool for you to do it. For Java applications specifically, you do need to be aware of the JDK version. People say just containerize it and it will work. That's not true if you containerize with the wrong version of the JDK. So for the older applications, make sure you containerize with the newer version of the JDK so that they become container aware. Okay. And also in terms of memory usages in the containers, sometimes you do need to know how much memory is being used. For that, you can use, in Cloud Foundry Build Pack, they have a memory calculator. You can actually use that to estimate how much memory you actually need to allocate for your container. And that has been pretty useful for me. And finally, if you do need to know exactly how much memory you are using in your microservice, in your container, so that you don't go over the limit, then you can unlock certain capabilities in the JVM itself so that you can actually print what they call the native memory tracking summaries. So you can see the breakdown between the native memory usages versus the heap usage. Again, something that's useful for your application before you go into production. Now, finally, right, after you design your application, after you design your repository, after you design your service-to-service communication, and now we can deploy the app. This is why I keep Kubernetes to the last, right? Finally, we get to talk about Kubernetes. Now, for the local development, we do want the developers to have some kind of fidelity to learn about Kubernetes. Okay? This is by choice, right? If you develop everything without Kubernetes, that is also perfectly fine, because you just have to package it up in this container and somebody else can deploy it. But it's also fun, and for this team, they wanted to learn about Kubernetes, and so we evaluated the different ways to use this, right? So the team actually started off with Docker Compose. That's not Kubernetes, but they started off with Docker Compose to run multiple containers. But now, because it is too much different from Kubernetes, from the environment they are actually going to be running on, so we decided to run Kubernetes locally. Okay, and it's a decision between, do you run a remote cluster or do you run a local cluster? There's pros and cons for each. We decided to go with local Kubernetes cluster because it's much easier for us to set it up individually, and everyone can experiment on their own cluster if they need to. And there are a couple of choices here. One of my favorite is this called K3s. So if you haven't used K3s before, it for me was one of the simplest way to get started on Kubernetes in a Linux environment. If you have Linux, just go to this page, and then you can say curl if you trust it, right? Just run this script, and in about 30 seconds, you get your Kubernetes cluster up and running. So for example, if I do the same thing in my Linux environment, I already ran it, and I can say kubectl get pods. No, I think I need to do a sudo here, sudo. Yeah, and I have my Kubernetes cluster up and running. This only took about 30 seconds when I installed it earlier, just before the talk. Okay. The other one is called kind. So let me see here. I do have sudo docker ps. Kind is another Kubernetes cluster environment that you can run on your machine, especially if you are using Linux. Yes, but kind stands for Kubernetes in Docker. So basically, as long as you have a Docker daemon, you can use kind. So you can probably do kind create cluster. Oh, kind. I think I have it here, right? And what this is doing is actually starting Kubernetes in my Docker daemon itself. So this is another way to really quickly start a Kubernetes cluster locally. And now you can deploy and test your application in your local Kubernetes environment. Okay. And this is also useful if you're running like a full end-to-end integration test where you do want to have Kubernetes to be running, but this is part of your CI/CD pipeline. Then you can use kind to start a temporary cluster for you and deploy everything into it. And then at the end of this test or at the end of this pipeline, you can shut down the entire cluster in just one command line. Okay, and that's super useful too. And then we have tools for our local development. So for example, here in my example here, I am using something called, I'm using IntelliJ IDE, but I'm also using something called the Cloud Code plugin, which is right here, Cloud Code. Yep. So here's Cloud Code. And for Cloud Code, we can actually add Kubernetes capabilities into your application as well, so that we can actually run your application in Kubernetes if you want to have that type of fidelity. Well, what does that mean? Well, first of all, we do need to create something called a scaffold.yaml file. Scaffold is really just a way for you to automatically detect changes in your application, okay, and then rebuild your container, and then redeploy your application into your Kubernetes environment, whether it's local or remote, so that it gives you a feel of or fidelity of local development, but it's actually running in a remote cluster potentially. Okay, and with the IDE, what we can also do is to say develop on Kubernetes. And if I click on the run here, what this will do is to actually code Scaffold, and based on this configuration, it's going to monitor my application changes in the source code, and it will actually go ahead and use gib, for example, to create my container. I think I may need to run this from somewhere else. But it will use gib to create the container, and then ultimately what this will do is to deploy everything into my Kubernetes cluster. And then finally, if I were to make any changes in my Kubernetes YAML files, it will automatically redeploy the stuff for me. So this is a really easy way for the team to experiment with different settings and configurations and just redeploy it and see if this is the behavior that they're looking for. Okay. Again, this is only done after you have done all the testing too, right? So testing is always first, but then after you think that your application is pretty much ready to go, you can use this capability to really easily, get that deployed into a Kubernetes cluster. On the right-hand side, you can also see a bunch of clusters here too. Like here, you can see a bunch of different clusters that you can choose to use, and everything can be integrated as part of the IDE. Okay. Now, let me move on just a little bit more. If you want to create your YAML files, there's the easy way, right? You don't want to create the YAML file manually, so you can use the command line like kubectl create to create the baseline of the YAML file, and then you can edit it later. Another really cool tool is called Decorate. We're not using it, but I found it to be really, really interesting. I might use it in the future in a production environment, right? I tried it out in non-prod, but I probably consider it. What Decorate can do is to automatically understand and examine your application. Like this is a Spring Boot app. Okay. Are you using Actuator? Yes. What port is on? Port 8080. Okay. And Decorate will automatically create the Kubernetes YAML file for you with the health check endpoints behind the scenes. It points to the actuator that you're actually using. Okay. So Decorate is certainly a tool to look at. Just like we don't want you to write Docker files. You can also avoid writing YAML files if you can. Okay. We talked about Scaffold just now. With the rest of the time, I just want to say one last thing, which is about really important contract in Kubernetes with your microservice, which is the liveness probe and the readiness probe. Okay, so when your application is running in Kubernetes, Kubernetes needs to know whether your application is alive, because if it's not, it will try to kill it when you restart it. And the second thing you need to know is if it's ready to serve traffic. Why? Because if you're not ready to serve traffic, it's meaningless to add it to the load balancer. Okay, so Kubernetes will check two things for you. One is whether your application is alive. And what you put in the liveness probe, you can respond this via HTTP. So if you respond 200 success, then you're alive. If you don't respond in time, then you're dead, and it will try to restart it for you. What is really important here is that a lot of times I see people putting health checks as the liveness probe, because health checks against the downstream health, like if your database is up. My question to everyone is, if your database is down, does a restart of your application help to bring the database back up? If the question is no, then do not put that third-party component in the health check for the liveness probe. This is very important, because if you do it this way incorrectly, then what you might get is a cascading failure. Imagine if another service who depends on you puts you in their liveness check and you failed, and now they're going to fail, and now your entire system is going to fail. Okay, so for liveness check, just keep it simple, just respond 200. For the readiness probe, this is where you can say, is my application ready to serve? Is the connection all established? Do I have all the cache loaded? Is my application ready? If it is, then we turn on the readiness probe, and now the Kubernetes will reconfigure the load balancer, and then all the requests will come through. Okay, and this is finally how you actually deal with graceful shutdowns. Okay, by tuning and understanding these lifecycle hooks that Kubernetes give you, so that you can actually have a really low downtime as you are deploying new versions of your microservices. If anything, you need to have these two probes. And then the secondary thing will be dealing with the graceful shutdown. And this is the proper procedure to actually have a proper graceful shutdown, which is that Kubernetes will send your application a SIG-term signal. And in Spring Boot application, for example, it handles that automatically. And then you need to fail your readiness probe so that Kubernetes will delist your application from the load balancer. Okay. And then, but this will take time. It takes about 30 seconds or so. There's a configuration you can add. And then once the Kubernetes removes you from the endpoint, you still need to finish serving the in-flight request. You don't want to shut anything down until you finish with all the in-flight transactions. And then you can shut down gracefully. And that is the anatomy of a really sophisticated graceful shutdown. Not every application needs it, but this is the one way of doing this. Okay. That being said, I think I'm pretty much in the end. Yep. So the road to production is hard, and there's a whole lot more that we have to do to just get to the production environment, right? So we have the VPC and NIT and all of these other things. I have a separate talk just to talk about all of these things, more things in detail. But just remember, development is not the same as the production though, because the production road is difficult. And with that, I'll leave you with the last slide, which is all the things that we talk about in the summary of the learnings that you can probably screenshot and have a good takeaway. Okay. So thank you so much for being here, and thanks for having me here for the second session.
Thank you so much, Roy. We are out of time, but I've got a couple of questions here from the guys in the Almadina chat. So Mario Dago asks, why does a mono-repo means build everything together? We can have a mono-repo with multiple projects and have multiple build pipelines targeting different folders.
Correct. Yes, that's also true as well. Yeah, absolutely. That's definitely true. But if that's true, then it might as well be easy to split it out as well. We definitely considered that option too. And we still chose a mono-repo as in, you build one thing, you have a root that builds everything. Yeah. But you're absolutely right. You can also have a mono-repo that has the services built independently from each other. Absolutely.
Another question here now from Jose Rosa. He asks, how much overhead does this Istio sidecars add to our services compared to using the Spring tools, for example?
As opposed to using the build like Spring stuff, right?
Yeah.
I actually have not done the research or the test myself. But if you think about it, they're pretty much trying to do the same thing. It's just one is externalized to an external service, and the other one is built in your application. That being said, I know that they have done a lot of tuning in the proxy itself. So it used to be not too good, but with Istio newer versions, it's definitely getting better and better. So I'll be interested to run that test as well. But just remember that proxy is actually written in C. So that proxy is built and battle tested by Lyft, the company here in the US, that they are serving their production traffic. So it is made to be very efficient. Now, of course, without the numbers, it's hard to say how much more efficient it will be. Yeah.
Okay, so one last question, so we can wrap this up. Mario Dago asks again, any suggestion for scaling up or down the number of instances of a microservice based on the number of requests, response time, etc., other metrics, basically?
Yeah, so the Kubernetes HPA give you the option to use CPU and memory, but that may not be the best indicator. One of the things I learned also previously was what defines the load for you. Okay, that's very important. What defines load? For the longest time, I think in my entire career in the past, I think about load balancing as just random load balancing to different instances. And that assumes every request produces the same load. What I learned from the gRPC team is, well, first of all, what defines the load? If the request defines the load for you, then load balancing based on the request makes total sense, right? That being said, if you do want to load balance on the request based on the request latency and also scale out because of it, I think that Kubernetes built-in will be slightly more difficult. What you might want to look into is the newer or the higher level platform like Knative. So with Knative, or even if you look at App Engine and Cloud Run, they all auto scale based on the latency of the request. But that's assuming it's because in their paradigm, the request defines the load. And so you can definitely do it. So for example, it will depend on quite a few things like your max latency or the pending requests as well. Because sometimes the load balancer will queue up the request in the load balancer. So you can see how many more requests is coming in, but it hasn't been handled. So there's the pending request, and there's the pending latency, and there's the actual latency of the request that can indicate slowdowns. And you can auto scale based on all of those. And to do that, you gotta look into something like Knative instead. Yeah.
Okay. So we have one last question. We are running way out of time, but we have George Nikolai here on the YouTube chat that asks, all of those should be done by the developer, and is talking about implementation changes in order to adhere to cloud native 12-factor, or maybe would you split these kinds of decisions and time between the dev team and infrastructure team?
Yeah, I think I wouldn't say that any decision that we made was a split decision from one group or the other. Okay, What that means is that, yes, in many companies, there's still the team, just from the organization structure, there are different teams. However, these decisions is important to have common understanding and agreement. So we don't actually, make decisions unilaterally on one team or the other. It's very important that we present the issues and the other team will chime in, right? We do this together and we document it together. That's very important. One thing I do want to say though is that because we are using Kubernetes and containers and Istio, for example, what I found personally that's really interesting is that the development team and the people who are creating the infrastructure, we are now speaking the same languages. Okay, it's like the development team might say, "Oh, I need to have a deployment to there," and the other team would immediately understand that they need a Kubernetes deployment. The other team would say, "We need 3 replicas." That's again the same terminology, or that we need an invar, we need something. So now we're sharing the terminology based on the Kubernetes terminologies, and that's really, really useful. Okay.
Yeah. So we really need to wrap this up. Thank you so much, Ray, for the talk, and thank you so much for the interaction with the guys. You have a lot of people saying thank you for a great session on YouTube chat and so on. And as I said in the start, we hope to see you back at Coimbra next year.
Same here. Yeah,
definitely not to make fun of our internet, please. A good one.
I'll bring my own hotspot. I'm just kidding.
I'm joking. Thank
if you guys,
so much, Ray.
If you all have questions, you can find me on Twitter or on Slack. Thanks for having me here.
Thank you very much, Ray.